welcome to Smart Energy use for poultry farms. Saving money and staying ahead of everything is key. We do understand time is money, so again, thanks for joining us. So we will keep to our time today, and hopefully today with my colleagues from NFU Energy and a surprise guest from Aris, we will be able to help you understand your energy use in a bit more detail, but of course improve things and maximize profits. So I'm delighted to be joined by Joshua, our assistant director here at NFU Energy, and he's the head of our utilities contracts management team. So excellently placed to be able to give some advice on the markets, your energy bills, and how things that can benefit your use on the farm. I'm also joined by Jonathan, one of our senior project engineers, and he's going to talk through some projects that you might be able to consider when moving forward, again, to maximise your energy use and move forward with maximising those profits on the farm. Again, our surprise guest is Sam Jensen. He's the general manager at Aris. They can help you monitor that energy, and Sam is going to talk you through how that can be managed using Aris. And again, we'll answer questions at the end. So let's get into it. Welcome to the podcast again with NFU Energy. We are the UK's leading and trusted energy consultancies, and as you can imagine, being part of the National Farmers Union, very, very well placed to be able to offer you assistance and advice on any type of energy usage where you are offering, consultancy on everything from energy management, of course, contracts, which Josh is going to go through, and how to maximise the benefits that his team can provide. Strategy is key, moving forward and maximising those profits, so we can give some good information and assistance on that. And of course, renewable energy and different projects that you can utilise and the experience within NFU Energy, which Jonathan will talk about through the webinar, and compliance as well, permitting and all different types of things within the compliance bracket. So well placed to be able to offer you all of these benefits with NFU Energy. So with that, I will hand over to Joshua, our assistant director and head of our UCM department. I'll let Josh introduce himself. Over to you, Josh.
Josh, you're muted.
Oh, apologies about that. So afternoon, everybody. So I'm Josh Robinson. I'm going to spend the next sort of 10 minutes or so just discussing the energy market, some of the changes that we've seen in recent years. I have around about 15 years of energy experience in total, with 7.5 of that being within the NFU Energy team. So I'm going to get straight into it. So what we've got here on our first slide is just the makeup of your general bill. So next 10 minutes, we'll spend just talking about these 3 different areas and how they're impacting bills at the moment. So on the right-hand side, you have the commodity section. It's making up just under 36% of an average wholesale bill at the moment. And that is largely driven by the market, what you see with President Trump, what you're seeing in Iran, what you've seen over the years with COVID, with the Russia-Ukraine invasion. So that's making up just over a third of the bill. We then have our renewables levies, the drives for a greener future, what a lot of the historic feed-in tariffs cover, and that makes up, again, almost another third of the bill under the renewables section. And then we have probably the biggest growing area, which is the delivery costs. So these are the big non-commodity charges that we're seeing. These are having some pretty hefty jumps year on year, and they've recently been forecasted on Chinuos, which is one of the largest increases in recent years. That's been recently forecasted right up until 2031, making up just over a third of the bill. So combined, that is generally the makeup of your bill. About a third of it is governed by events around the world. 2/3 of it is things that are happening much more closer to home. So if you can just move to the next slide for me, please.
Oh, bear with me, Josh. It's seems to have stuck a little bit.
just while Brian's finding that, what I will do on the next slide, I'll talk about the commodity elements and just go into a little bit more detail. So one of the first areas that we are seeing on the commodity side of things is the weather patterns. Over the last few years, we've either had a lot of drought or a lot of drought or a lot of rain. These are having a recurring theme. They're having an impact on prices, especially in the poultry sector. They're seeing fans used increasingly and energy bills as a byproduct of that increasing as well. Generally speaking, we've had a continued upwards market trajectory. So as I said, even if we went back 5-6 years back to COVID, since then we've still seen the wholesale price of energy rising year on year. Geopolitics are obviously having an impact in the poultry sector. Ammonia, urea shipments have obviously been massively impacted. What we've seen, everybody's well aware now of the Strait of Hormuz. It's also impacting fertilizer for arable crops, which then do form the foundation of a lot of poultry rations as well. So we're seeing members being hit from multiple different areas. From a commodity perspective, if we looked at it a couple of years ago before Russian invasion of Ukraine, a lot of pipe work and a lot of energy moved around the world underwater. After the Nord Stream pipelines were shut off, a lot of that was just moved above water. And what we're seeing now, the infrastructure, the closure of a strait halfway across the world is having big impacts on us, but over in the UK as well. So if you can move to the next slide for me. So what we've done is since sort of 2021, we've tracked the average cost of electricity and gas. You will see a familiar theme. When one rises, the other one rises, albeit you do have that massive spike in 2022, which is when we talked about the sort of turning off of the Russian pipelines into Europe, almost a starvation of energy. It sent the market crazy. We capped it out at 75 pence. However, we did see prices as high as 120 to 130 pence per kilowatt hour. You can see a small spike around about sort of end of February, early March, where you had the Iran situation. Whilst you did have a bit of a jump in the price, it was nowhere near as bad as it was previously. And this is largely due to the fact that after the Russian invasion of Ukraine, there was a concerted effort by a lot of European nations to find better storage. That's also happened back in the UK, where there were 4 storage plants reopened. Storage in the UK went up by around about 60%. So it's not as bad as it could have been, albeit it's not as good as where it was 6 to 8 months ago. So if you can move to the next slide for me. Yep. So when we look at sort of policy reasons and delivery reasons, in short, where is this second third of the bill? So this is a lot of stuff that's a lot closer to home. We're seeing a lot of a big push on the drive to net zero, increasing green energy availability. But as a byproduct of that, we also have an aging transmission network. I always say to members when we speak to them, when was the last time you seen one of the major pylons upgraded? And it is slim to none. There is on Chinuos alone, best part of an £80 billion investment required over the next 5 years, and a lot of that is coming from the end user or the domestic customer by the rises in delivery charges. We'll come on to banding and rebanding in a little bit more detail, but just a couple of years ago, every meter in the UK was given a band. The band directly correlates with some of the charges that you're paying, and there are some ways to make changes to that. The grid is also really struggling with balancing generation and demand. So what we're seeing is there is a lot of offshore wind. The problem is that can't make its way back onshore because there's not enough capacity in the grid, or there's too many constraints in the grid to take the energy. So this is where the rebuilding of the grid is largely required. NESO, who are National Energy Systems Operator, they're continuously forecasting updates. If we look over the next 5 years, up till 2031, you would largely see an increase in these delivery charges every single year before it then begins to tail off. We're seeing a lot of power moving across the UK. So we were at the Lincoln show earlier this year speaking to members who are basically having exploratory digs on their farms with regards to bringing energy across, taking it to where it's needed most in the UK, which in a lot of cases tends to be in the London region. So as we said, sort of over the next 5 years, there's something called RIIO-3, which is basically a formulated forecast on some of those charges for the next few years. And it's really, really important that we sort of stick close to that to be able to give the best advice. So if you just move to the next slide for me. So this is just a little bit more detail where I was talking about banding. What I have done is I've almost ring fenced in orange where we would see a lot of poultry users fall within. So you do have sort of 5 different classifications of meter in the UK, starting with your low voltage and going right up to your sort of largest meters in the UK as well. What I've done is I've tried to sort of keep it to where it needs to be, but in most cases we would see low voltage meters, which you can see they're banned for in the blue section. These are generally based on usage, and you could expect to see a standing charge. You can get them as low as 0, and they normally cap out at around about £6 a day. The capacity of the meter does become quite important. So for those of you with half-hourly meters, we can see those standing charges start at around about £6 a day, and they can be as high as £56 a day. So just having the meter banded correctly can have a massive impact on what you're paying before you even turn on any energy at the property. There are ways that you can navigate and surf the bands, but a lot of it is dependent on how much availability you can give back to the grid. So we do have a service that looks at that for members and for non-members as well, but we think it's definitely very important that we do mention that, because these are the unknown areas of the grid that many people fall foul of or are just completely unaware of. So if you can move to the next slide for me. Yep. So when we look at sort of specifics around the poultry sector, many of our poultry units that we look at hover around about the 70 kVA mark. Now, when I showed you the previous slide, non-half-hourly metering, or the blue area, ends at 69 kVA. And we tend to find new units tend to be fitted in at 70. That can pose a problem because it can change straight away you being able to get a 0 standing charge product versus taking a minimum standing charge of about £6 a day. Over the course of the year, that could easily amount to a couple of £1,000, and over the course of a contract, that can be a hefty difference. And this just creates banding uncertainty. It is something we can really sort of help with and direct on. We are seeing, sort of specific to the poultry sector, the usage per bird is being reviewed more and more nowadays, especially with seasonality. If we look at the weather over the last sort of 6 to 8 weeks, we've had very, very few cool days, and it is seeing fans for ventilation, cooling requirements really, really increase, which is also putting a surge on those energy bills as well. In terms of the specifics, again, we are looking at what's known as a time of use tariff. So what we have done with a lot of suppliers, and we're working with 3 key suppliers on a project at the moment, but we are looking at usage patterns when your energy is being used. Largely speaking, we would look at a peak in the market where when it's hottest, you would have the most solar availability as well. So the argument going back to the grid is if there's a lot of solar and there's a lot of energy being generated, why is that not at a cheaper price at that time of day? So time of use tariff does actually morph 3 different times within the day, depending on availability on the grid. So we are in early stages with suppliers on that, but we are looking at an initial trial towards the end of this year, and we will have a poultry specific tariff available in the coming, I would like to promise to within a year, but we are working with suppliers on that. Probably last point, really specific to poultry as well, smart metering is a key requirement. There are already suppliers, and we can announce sort of British Gas at the moment who we work with, but they do have something known as a peak save agreement. And if you have a smart meter and it's compatible with British Gas, they are currently giving away energy free of charge within a window on a Wednesday afternoon. It's a trial basis, and it's in order to obtain data going forward, but you can only fall under these tariffs where suppliers are giving away the excess free of charge if you have a smart meter. So for those without one, I would definitely encourage speaking to your supplier to get one. It will be a necessary evil going forward in sort of looking at the new tariffs and the new scope of change. If we can just move to the next slide for me. So yeah, so the last sort of area that we look at is we're looking at the renewables element. That's that final sort of 30 to 35% of the bill. We're seeing a lot of these payments. Some of them are expected to fall off. So if we look at sort of the FIT scheme started in 2003, we're expecting some users to start falling off that at around about 2028. So some of those levies will start to fall in some areas. We're looking at increasing technologies and the mix of technologies that we're seeing. Historically, there's been a big surge in solar. We're starting to see a bit of an uptick in wind now as well. And wind works really, really well because it tends to sort of fall in line with when the grid needs the energy most, generally first thing in the morning, 6:30 till 8:30, and also the afternoon slot, 4 till 7 p.m. The import versus the export is still an argument that's in motion, but what we are finding with some people, they're installing renewables, and then they're finding it drives them into the next band up because they're not offsetting enough back to the grid. So that is a really, really interesting part that we're sort of spending a lot of time on at the moment, really ensuring that when installations are being put in, they're taking customers into the next band, because that can then impact return on investment. DNOs, so district network operations. We do spend a lot of time speaking to the likes of National Grid, Northern Power Networks, Scottish Power. We are seeing appeals are on the rise. There are a lot of people that are now, especially with the rising standing charge, looking at giving energy back to the grid, but the appetite and the ability to reward people for doing that is still not there. So we are seeing a lot more appeals into the grid with regards to rebanding customers, and there are quite a few that we've done successfully as well. And then we're looking at sort of grid versus usage patterns. So as I said, we've spoken about sort of time of use a little bit already, but we are looking at the availability of the grid versus the usage of, in this case, the poultry sector. Where are the caveats? Where are the really, really interesting parts that we want to look into more? And as you get into that renewable world, where would it be a case that if you've got batteries, you would actually utilize the batteries at times where the grid has a shortage of energy? That will allow you to almost ride the wave and not have to pay the excessive prices the grids will look at promoting on half-hourly metering especially. Just final slide for me. So in terms of outlooks there, well, this one's just a bit of a slide, sort of cost of oil versus the cost of energy. We can largely go past that, but you can see there's a bit of a trajectory, a bit of a similarity there. But largely speaking, you can see the energy price wasn't impacted as big as it could have been when you consider the differences on the oil price. Just next slide for me. So in terms of the outlook, some of the areas that we're looking at and where we do see a bit of brightness. So we're looking at sort of investment in LNG terminals. Mentioned it earlier, but there are plans for another terminal to be online for 2030. This just helps with storage. It helps with the reliance of energy. The more we have stored, the easier it is to get through those winters. There's a lot more pressure being placed on NESO at the moment. We're at the forefront of doing a lot of these talks with the likes of DESNZ, giving feedback into the grid on what are the barriers to change. We have seen some changes already. So it was agreed in 2025 in October, and that it was basically there was no longer a requirement to guarantee 90% storage in the country by the 1st of October. It has been pushed back to the 1st of November now, which is a positive because historically there was this big rush for energy earlier in the year, which drove the price up even higher. So by opening that window out a little bit more, it's actually helped a little bit. As I said earlier, we are doing the time of use scheme, so we're working behind the scenes with another number of suppliers with a key focus on the poultry sector. And as we've already touched on, brighter outlook, smart metering will bring in more options. If we look at the Northern Irish market, there has been a farming tariff for the best part of 15 years already, and we're driving a lot of change to try and get something very, very similar brought into sort of England, Scotland, and Wales as well. Next slide for me. So in terms of outlooks as well, these are just some of the working groups. I won't spend too much time going through those, but there are a few pickouts. If you do choose to go onto Google and just type in DCP 466 or 465, you can see some of those that are definitely relevant to the poultry sector. 466 especially will be a change that we're awaiting authority decision on. It's been a working panel that we've sat on for the best part of 6 months now, and it's looking at driving a change whereby customers are able to give a small amount of energy back to the grid and to be recognised for that with a lower standing charge as well. So we are hopeful with some of these consultations, they will come to the fore and they will really sort of change the face of what people can save going forward. And then I think there is one more from me. Yeah, so just changing the landscape, some of what you can do. So in reality, there are changes that you can make. We can look at securing supply and reducing reliance on the network with on-site generation, the likes of having solar and utilising it yourself. There is the option for private wires to actually move it from one area of the business to another. We have to look at the argument increasingly. Do you take a fully fixed contract or do you look at a flex contract? What we are seeing is flex in 90% of cases can be cheaper, providing it's traded correctly. So there is still that argument, and these are ways that increasingly going forward we will need to look at. Fixed contracts have largely had a reopening en masse in recent years because the grid have levied new charges. Suppliers have been able to reopen it, even if it was historically deemed to be a fixed contract. License exempt supplier, which is the ability to sort of escape some of those charges, is a big area that we look at as well. And then I know we've talked about banding and innovation already, so I won't spend too much time on those again, but we can open it up for questions at the end.
Thank you, Josh. That was really informative, some really good points there and some things to look forward to. And if anybody would like some more detailed information on their specific cases, of course, details will be at the end, so we can, or you can get in touch with Joshua and his team there. But over to you, Jonathan.
Thank you very much, Brian. We just go to the next slide, please.
Oh, sorry.
One more. One more slide. So, yeah, there we go. Thank you. Excellent. Yeah, good afternoon. Today I'm through some of the practical ways poultry farms can reduce costs and hopefully become less exposed to future electricity and fuel prices. There's no single technology that will be right for every poultry farm. Across the sector, there's so many different systems at play with broiler farms, layer units, pullet rearing sites, and they all can have slightly different energy demands across the year. Things like shed age, ventilation design, heating systems, stocking arrangements, that can all affect where the best opportunities will be for those individual farms. So the aim of this presentation is therefore not to recommend just one ideal system. Instead, it's going to be focusing on sort of a repeatable 4-step process to try and drive down energy demand. Next slide, please. I think first and perhaps most important, something that we always try and encourage is understanding where energy is being used. You can't meaningfully know how effective your changes and improvements will be if you don't measure how much energy you're using first. The sector already measures a lot of KPIs for animal welfare, so this would just be an extension of this for energy systems specifically. Next, it would be a case of creating benchmarks on a shed-by-shed basis. This allows you to compare whether individual sheds are performing as expected. The measured data will also allow you to identify the biggest opportunities for improvement in your specific use case. Third, improving the efficiency of the existing farm, starting with controls review, maintenance, and relatively simple changes before then considering the larger investment items. Finally, we'd encourage looking at renewable energy, including solar PV, battery storage, microanaerobic digestion, and how these technologies may help reduce the amount of electricity purchased from the grid. The key messages throughout this is that efficiency comes first. The less energy the farm wastes, the easier and more cost effective it becomes to supply the remaining demand from renewable sources. Next slide, please. Thank you. The main farm electricity bill tells us the total cost, but it does not explain which shed or systems are responsible typically. Where practical, each shed should have its own electricity monitoring. Ideally, this should be on a system level so that you can identify which systems are to be prioritized. As well as electricity, there's also a large demand in some cases, especially with broiler units, for heating fuel, and that should also be monitored and measured, whether it be biomass for the renewable heating incentive or natural gas or LPG, whatever system that is. That should also get recorded by shed or by crop. The most useful information normally includes granular electricity data, ideally sort of at least every half an hour, the heating consumption, your number of bird placements, the depletion dates of the crops, outside temperatures, which can also affect those systems directly. And also an important one, sounds simple, but just to monitor it, is electricity use while the shed is empty. So when you think that the shed is idle, not doing anything, is it definitely doing that? And making sure that there's no waste. Excuse me. We should also identify seasonal peaks. So summers are getting hotter. We've got to identify whether or not systems are keeping up with that, whether or not cooling systems are going to have to start being introduced, or whether or not there's strategies we can take to avoid that, to minimize energy consumption in those extreme heat periods. And then, no, sorry, could we just... and I just wanted to finish on welfare codes require ventilation, heating, and environmental systems to maintain suitable temperatures, humidity, and air quality. Monitoring is therefore about achieving these conditions efficiently, not simply reducing fan or heater use. Next slide, please. National benchmarks can be useful, but I think the strongest starting point is often internal benchmarking, making something that works for you and your systems. If a farm has 4 similar sheds, compare them under similar conditions, and if one repeatedly uses 15 to 20% more energy than others, investigate why. There could be many causes. For example, it could be faulty sensors, different controller settings, poor insulation or air leakage, age of the building, dirty fans, etc. But the comparison must be fair. A winter broiler crop shouldn't be compared directly to a summer crop without allowing for weather. So this is something that you will continually improve on year and start building up your baselines. And newly stocked sheds should also not be compared with birds close to depletion. Energy should also be considered alongside production. Low energy use is not necessarily successful if it is associated with poor growth, lower egg production, poor litter condition, or lower bird welfare. These are things that should not be impacted by trying to reduce your energy. Move on to next slide, please. Many of the first opportunities shouldn't require major capital investment. It should be just reviewing things such as control sensors, temperature, humidity, checking them against independent instruments to make sure that they're still within tolerances. Some examples could be that poorly positioned or inaccurate sensors can cause unnecessary heating or ventilation, and purely just from repositioning that could lead to significant energy savings. Ensuring that heating and ventilation systems are communicating and working together. We don't want them fighting with each other, wasting energy throughout the year. Ensuring that drinker leakage is corrected quickly to prevent any wet litter. Wet litter will increase the moisture and ammonia, which then may require more ventilation and heating to fight against that. And finally, sort of checking schedules such as your lighting regimes, feed systems, manure belts, etc., pumps, make sure that they're not operating through either empty periods or for longer periods of time than you would typically expect. Reviewing the data should allow you to see patterns, allowing you to understand when systems are being used. Maintenance tends to protect both energy efficiency and bird performance. Next slide, please. Moving on to some of the higher investment improvements. The first major opportunity is often ventilation systems, especially with the heat that we've been having. Upgrading fans to the likes of EC fans, so that's electronically commutated fans, permanent magnet fans, or highly efficient AC fans with variable speed controllers. They're all commonly available technologies. That which one you use is generally less important, more so than the rated kilowatt hour per volume of air delivered. So always trying to investigate what is the lowest energy consumption fan that can achieve your minimum ventilation requirements on the market for your particular use case. Variable speed ventilation can reduce electricity considerably, where fans spend substantial time operating below their full output. One commercial poultry study found variable speed control used approximately 25% less fan electricity than just purely on-off operation under its test conditions, although results will always vary based on your specific setups, so can't always promise that 25% improvement. Heat recovery is another major potential energy saver. It perhaps will suit broiler and pullet sheds more so than layer sheds, especially where heating and minimum ventilation operate simultaneously. Warm exhaust air in these scenarios is used to preheat incoming fresh air, so there's a consistent exchange. Published field research found that substantial reductions in gas consumption occurred on some broiler farms that trialled the technology. However, the evidence for total energy savings was a little bit less clear, because whilst that will save heating energy, there is also potentially a slight increase in electricity demand. Therefore, doing a full case-by-case study is certainly beneficial. It's also worth noting that with ammonia becoming an increasingly important planning and permitting constraint, active abatement systems may become necessary. Therefore, it may be sensible to combine ammonia scrubbing systems with heat recovery ventilation in the future, because the two systems can work side by side to achieve their goals. But the main driver for the scrubber is likely to be planning and compliance rather than just energy payback itself. Next slide, please. I just wanted to touch on this because it links back to something that Josh was bringing up on sort of grid connectivity capacity and how that is getting quite punitive at the moment if you're increasing your demand. So many poultry farms, they either already operating or considering operating on water-based heating infrastructure. So some people may be considering heat pump technology. They are a low carbon source of heat, which is fantastic if you have sustainability goals and aspirations that you want to meet. However, it moves a large part of the heating demand onto the electricity supply compared to traditional systems. And the annual electricity consumption may look manageable on paper, especially if you've got solar or AD to offset that electricity demand. However, the more important question is what happens during the coldest period, especially, for example, solar not being particularly useful in the winter. And if your sheds are all being heated at the same time with your operational management regime, you might find that your grid demand is significantly higher. So as these grid demand connections are currently an area of active reform, standing charges over the next 5 years are getting quite expensive. So switching to a heat pump may trigger the need for a grid connection upgrade, which could then potentially take you into higher banding. To give an example, on a larger poultry site where it might require 1 megawatt of thermal heat to heat all the sheds at the same time in the peak winter heat demand, that would be equivalent to potentially up to 400 kVA of additional capacity if it was to be provided by a heat pump. Could we just pop onto the next slide, please, Brian? So just to give a sort of representative idea of what that would mean on paper, is that if you were, for example, with a connection of 200 kVA, here we can sort of see the impact of upgrading to a 600 kVA connection when accounting for the additional heat pump that was to be installed. You can see that you would jump up from band 3 into band 4. and then also with the additional capacity charges that you've got to pay, you're looking at fixed costs in excess of an additional £20,000 per year moving forwards. And the rate of increase that we're seeing over the next 5 years, that could potentially be well in excess of £150,000 to £200,000 in that time period. That's just the fixed standing charge. That's not accounting for any operational costs. So you must be confident that the system will provide enough operational benefit to absorb this fixed cost, whether it's going to be cheaper than your alternative heating system moving forwards. Otherwise, it's something that you certainly want to get a detailed feasibility study to consider. Next slide, please, Brian. Solar PV is likely to be the most widely applicable renewable technology for poultry farms. It's a good match. Ventilation, feed systems, egg handling, etc. They can create quite a significant daytime demand for the layers. Broilers and pullet demand is also considerably high during these times, especially in the summer when it's getting hot with increasing ventilation requirements. So we have a lot of evidence that both systems are proven to benefit greatly from solar across the sector. The aim should not necessarily be to fill every available roof. We recommend doing a more detailed study of looking at available roof space and then also other factors such as the half-hourly demand profile, expected self-consumption to ensure that you're maximising your value for money, looking at things like the grid export capacity to understand if you can potentially earn additional revenue from your system without straining the wider network. Consideration for future electrical loads. Are you going to install an expandable system? Are you going to account for adding another shed in the future? And also things such as roof condition and the remaining life of the sheds. Batteries are also becoming more competitive as battery costs continue to fall. As well, up and coming is alternative battery chemistry that can also change the economic benefit, which are slowly being introduced over the next 5 years. Cheaper alternatives are coming into mainstream production, stepping away from expensive lithium to more common materials such as sodium. So whilst they would have an implication on the weight of battery storage, if it's a static installation, that's less of a problem. A battery may also be able to add value, stores the surplus solar, reducing short electrical peaks, and is also able to make use of cheaper time of use tariffs that we're exploring to try and introduce to the poultry sector, increasing their value for money. As well, advanced energy management systems are also much more common, helping battery systems optimize how they support energy demand in a relatively hands-off fashion. Next slide, please, Mike. Anaerobic digestion offers something that solar cannot, relatively steady generation throughout the day and night, 24 hours a day, and it offers this consistently throughout the year. A CHP engine can generate both electricity and useful heat on a suitable site that heat may support shed heating or other farm processes. However, poultry manure and litter are not necessarily straightforward AD feedstocks. Layer manure may be produced and used relatively continuously, whereas broiler litter is removed in batches and will need storing. And additionally, poultry materials are rich in nitrogen. High ammonia concentrations can inhibit the biological process, meaning the plant will need co-digestion with carbon-rich whole crop silage and wet feedstocks. Recent reviews continue to identify ammonia as one of the main technical constraints in digesting poultry manure in isolation. The business case must therefore begin with looking at the quantity and consistency of the feedstock that you're producing, gas yield testing with a specific co-feedstock mix, the availability of co-feedstocks to ensure that you can continually operate the system, trying to balance the year-round heat production. Can you utilize that effectively on site? And digestate storage and land availability to be able to spread. There's also planning and permitting and operational capacity constraints that must be considered. AD can provide valuable baseload energy, but it must be designed around the feedstock, not necessarily around the electricity bill. Thank you. Next slide. So that brings my section to an end. The main message that I hope to have got across is not that every farm should install the same equipment, but the first step should be to understand where electricity and heat energy is being used on the farm. The second is to compare sheds and identify where consumption is unusually high. Third is to address the practical improvements, from ensuring you have the right control strategy and maintenance regime through to more efficient motors, fans and heating systems. And finally, the farm can make an informed decision about renewable generation. A sensible first action might be as simple as monitor one complete flock, compare that to another similar shed, investigate the poorest performer, correct the obvious faults, then model the renewable energy opportunities. Using less energy, use it better, and generate as much of the remainder as practical. Thank you.
Thank you, Jonathan. Appreciate that. Some really good information there. And if anybody is interested in looking into some renewable technology, want to know more about proposed projects that you might have in mind to, help with your renewable on site, Jonathan and the team at NFU Energy can provide full feasibility studies and, of course, a really detailed return on investment, so what to expect. So with that, I'm really happy to introduce Sam Jensen from Aeris Energy Solutions, and he's going to talk you through about Aeris and what they can do for you in the poultry farms. Sam, over to you.
Thank you, Brian. We might be able to skip straight to the next slide there if you want to. Yeah, so my name's Sam. I'm General Manager at Aeris Energy Solutions. As you can see, we've been around now around 30 years, started life out in Europe, manufacturing electrical components, before sort of around 15 years ago moving into LED lighting. We manufacture and install LED lighting throughout the globe. Natural progression from LED lighting was solar and renewable energy, and looking at how we can help clients become more efficient, utilizing the products that we offer. As you can see, we've worked with a number of companies within the UK, most you've probably heard of. But today, the reason I'm on the call today is essentially to look at the energy monitoring. Jonathan touched on monitoring and the importance of it, and we have a shared belief as a partner with NFU Energy that it is of the utmost importance, first and foremost, to measure and understand your energy consumption before you can explore these higher capital investments. So today I'm going to talk a bit about how it works. It's a very simple piece of equipment. They're essentially CT clamps that go on circuits, so we can identify your heaviest load, your highest consuming circuits, and we can install CT clamps relatively easy. It's a quick install with very little impact on you as a business and your operation. What that will do is that will allow us to transmit that data wirelessly to a dashboard where you can view more granular detail. At the moment, a lot of the clients that we deal with, the level of detail they'll have at best is their half-hourly consumption site-wide. Whereas it can tell you some things in relation to what time you are using your energy and whether there's any anomalies in that. There can be small amounts of data pulled from that, but with monitoring in this manner, you're essentially breaking it down into circuits. Your timings goes from half hourly to essentially every 5 seconds. You're pulling data of when you are consuming, and you will see that on a dashboard, which will provide you with live data, so a real-time dashboard, so you can see exactly what you're using, where you're using it, and as Jonathan touched on, it allows you to it makes it easier to create those benchmarks with that data, as it is all logged, and you will have a historic record of your consumption and where. As like I say, as we've touched on, the first step to reducing your energy consumption and reducing that reliance on the grid is essentially benchmarking your overall consumption and understanding where and what that waste potentially could be. Just want to move to the next slide, please. So this is the equipment we utilize to monitor. It's very simple. It's almost plug and play. It will be on your distribution board or your main income or your section panel. We will utilize the power within that, and we can either put Rogowski coil for the larger supplies, right down to a small 50 amp CT clamp for a minor circuit such as lighting or something like that. We can do Wi-Fi, we can do wired, and we can now do 4G. So it would be a case-by-case basis to understand what the most appropriate communication method would be. What it allows as well is with the plug-and-play feature, doesn't mean you have to go out and invest heavily in sort of site-wide monitoring. You can utilize individual circuits, and you can then actually move that from circuit to circuit should you wish with relative ease. But you can also identify the circuits you want to measure rather than doing, like I say, site-wide. It can be individual, and it allows with the plug-and-play feature to then look at automation and controls. Whether that be turning things off, turning things on, setting alarms, setting warnings. There's many things you can do with the SMAPI infrastructure that we use. Next slide, please. Why energy? Why would you look at energy monitoring? Like I said, we have touched on this. First and foremost, identify, eliminate waste. And when you're looking at these larger investments, these investments very much rely on your current energy consumption and what you're using to calculate return on investments. Now, when you start looking into those investments, you want to make sure the energy that you are consuming is the energy you need to consume. So the investment in the larger sort of higher expenditure projects, you can ensure that it's efficient and is optimized to what you actually need. Now, our history with clients, we've seen payback within 6 to 12 months of having the equipment fitted. So there is a return on investment in the actual monitoring, with industry standards set at around 5 to 10% in reduction identified by the monitoring. It will identify that, but it is reliant on you as a business to take the required actions to reduce that energy, whether it be behavioral changes, whether it be automation, or whether it just be working more efficiently. This will allow you to identify those opportunities for investment. Will also allow you to create a plan of where investment is best made for the largest return on investment. And once you understand your data and your consumption, and it will then also validate that investment. So it does work nicely on that journey, because you'll have the data as to what your consumption was pre, and then you can look very easily and compare once you've made the investment, once you've had that project, whether it be solar or whether it be the number of projects that Jonathan talked about. You can see quite in real terms that investment has paid off. So it will give you that comfort. And just as a side, slightly away from energy and consumption and reducing energy consumption, it will also identify, you can tell a lot about energy consumption on machinery, whether or not that there's potentially an abnormal energy consumption, whether there is a fault within that machine, and you can sort of look at preventative maintenance rather than waiting for something to fail, which then has a knock-on effect on the business. So it's as a side benefit, potentially away from the energy benefits, you can really start to understand whether your equipment is working how it should, whether there is any requirement for preventative maintenance, and therefore it actually extends the lifetime of your equipment. So it really is, from our point of view, it is the natural place to start before going down that journey of focusing on reducing your energy consumption as a whole, and looking to save as much money as possible within the current market. Thank you very much for your time. Cheers, Brian.
Yeah, thank you for that, Sam. That ties in perfectly with with Jonathan, on his first point about understanding and measuring, where you're at with that baseline, and of course ongoing monitoring of it. So great bit of information there, Sam. Thank you. If you do want some more information on the the system that Sam's just described to us, please get in touch with us. Those next steps tie in quite nicely with that understanding, comparing where you are, improving, generating and managing. We can help with all of those steps within your business to maximize the profits that everybody's looking for. So if anybody does want more advice on these different types of technologies, or indeed on any of their utility contracts that they have, please get in touch with us. The telephone number is there, and of course the email address is there, and Josh, Jonathan, the teams, and of course Sam will help as much as we can to guide you through these times. So with that, I'd like to thank Josh, Jonathan, and of course Sam for their part in the webinar and the presentations and the excellent information that they've brought forward there. I do hope it's helped. And of course, again, if you do need more detail about specifics to your business, then please get in touch. And with that, thank you for joining us. And I'll just move into any questions that we have. So I'll just check the Q&A chat and see what we have in there. If we have any questions at all. Let's have a look. I think if I'm honest, one question I would like to ask both Josh and Jonathan, to be honest, what is one thing that poultry farmers could do out of all of the technologies and different things within contracts and commodities and non-commodities? Josh, what's one thing that you would advise a poultry farm just to take up first and really pay notice to?
I think the key one for me is to understand the capacity of your meter.
Right.
If you have your data, it makes it very, very easy to look at whether an immediate saving can be recognised. I would say that's probably a key one. Perfect.
Yeah. So if anyone needs help on analysing that, we do offer that as a free service to our members, of course. Jonathan, one thing from you that you would like, if there was one takeaway, that what would you say was the best thing that a poultry farm could do to improve the business or the energy use on site?
I still stand by the fact that it's fundamentally trying to benchmark the individual sheds so that they have comparison across their business of underperformers, better performers, and trying to identify why that might be the case. Just certainly knowledge and data really is paramount importance to any future improvements.
Perfect. Okay, thanks for that, John. And as I mentioned just a few minutes ago, there, that ties in very well with the products and services that Sam and his team offer to us as partners to the NFU Energy to monitor and measure what's happening in those particular sheds, maybe. So, thank you for that. Thank you, everyone, again for joining us. If there are no more questions, then I'll let you get on with your busy days, and we'll look forward to seeing you again very soon.